Welcome everybody to our multi-sector dynamics webinar. This is a webinar that's being hosted by the MSD Human Systems Working Group, of which I serve as a co-chair along with my colleague Christian Klassert. And today we have the pleasure of hosting a presentation by Dr. Dan Brown entitled Opportunities in Spatial Agent-Based Models for Complex Land System Science. Just before we dive into the content, we've just been making it a habit in these webinars to lay out some common ground rules. And so first and foremost, we really just do want to promote a productive and inclusive environment during these sessions. So we ask of you all just to be considerate, respectful, and collaborative as we engage with both our speaker and other participants today. Throughout the call, please do stay muted unless a facilitator calls on you to speak. When it comes Q&A time, you're welcome to use sort of the raise your hand feature in Zoom. Or you can also just use the chat functionality in Zoom to drop in questions or comments along the way. All right, in terms of agenda for today, we'll of course dedicate the bulk of our time to hearing from our speaker, Dan Brown, but we're gonna lead off here with some general COP and working group updates. And we'll leave about 30-35 minutes for Dan's presentation, and then about 15 minutes at the end for Q&A. And I do want to just check in, Pranav and Christian, are you able to monitor the waiting room and admit folks as they enter in?
Sure.
Okay, great. If it's not working, just holler at me so I can do so on my side. Okay. All right. So this is probably familiar to most of you on the call today, but for those of you who might be new to the multi-sector dynamics community of practice, a good way to get familiarized with our interests as a research community would be to check out this vision report that was published by the MSD Scientific Steering Group early last year. It's available at the website seen here, and you can also access via the QR code as well. I also wanted to call attention to a special issue that is being organized by the multi-sector dynamics community in their future. The title of this special issue is Advancing Complex Adaptive Human Earth System Science in a World of Interconnected Risks. This is actually an issue that's currently live and accepting submissions. And as you can see, will be open through end of next year. So still plenty of time to submit. For those of you who are also attending the inaugural MSD workshop at UC Davis next week, just a heads up that a lot of the focus and energy in that workshop will be around sort of identifying and catalyzing collaborations that can hopefully lead towards submissions in this particular special issue. So just something to get on your radars before many of us congregate in Northern California next week. In regards to upcoming activities specifically for our Human Systems Working Group, again, for those of you attending UC Davis, the UC Davis workshop next week, among the many breakout sessions that will be available is one that will be sort of significantly lean in the human systems modeling direction. That's called Better Capturing Human Actors and their responses to emergent risks. And I'll be leading this session alongside with Krista Brelsford and Wei Ping. So it will be somewhat of a joint effort between the human systems, urban, and energy transitions working groups. And I do also want to note here that of the many oral sessions that we'll be having at AGU next year, or this coming December, one of those will have also a strong human systems modeling bent that I have listed out here as well. All right, so just in the next few minutes before I hand it off to our speaker today, I did want to just provide some more sort of scientific context and background to our efforts as MSD Human Systems Working Group. So for the first couple of years, we've really centered our efforts around the development of this new typology for characterizing human actors in action in MSD models. This typology is described in detail in a publication in Earth Future. And in all of our working group activities, we've been trying to sort of frame our discussions around human systems modeling from the context of this unifying typology. So I did want to describe some of the key components of it to hopefully set the stage for Dan's talk today as well. The typology itself is organized around what I'd call some very seemingly simple questions. And I'll review the first two of these here using just one of the visual tools that we've developed in the typology. So considering that first question and the first two questions of sort of who are the modeled actors in these MSD systems and what are their actions? One of the visual tools we introduce in the typology is what we call this canvas of human action. And if you think of the canvas as sort of this XY space that you see here, along the Y dimension, we've developed sort of a generic conceptualization of actors in multi-sector systems, in which we conceive of three categories defined across these role categories. So at the top, we have what we're calling our governing actors. These are those actors who are involved in defining sort of informal institutions through which other actors are legislated, financed, regulated, monitored, and so forth. Secondly, we have what we're calling provisioning actors. These are those actors directly responsible for the delivery of a good or service. So a classic example here might be, say, an energy or a water utility. And then thirdly, at the bottom of this canvas, we have our utilizing actors. These are those actors that are actually receiving some product, good or service and applying it towards some human end use. So that's sort of the Y dimension of the canvas. And then along the X dimension, we're defining these time scales of action that can range from near-term actions, which occur on a, say, daily or an hourly basis, to longer-term actions, which might take place only sort of decadally or centennially. And what we can do then is take this sort of canvas to organize either the whole sort of realm of candidate actions one might include in a model, or to represent those actions that are actually sort of embedded within a model. So if you just kind of take a look at this canvas and look at the lower left extreme, you might define individual households at that utilizing level that take daily action around commuting or consuming food. And on a much longer time scale, these same households might make decisions around resettlement or adopting new technologies, right? And then you can also start to think about these timescales across the different actor categories. So a governing actor, for example, might enforce regulation on a daily basis, but new legislation or legal ruling might only be enacted decennially. So this canvas is just one visual tool that we introduced in the typology. And it's again a way just to organize sort of how we think about actors and actions as they're represented in our models. So hopefully that just gives you some background context for our working group discussions and a lens through which we can kind of move into Dan's talk today on agent-based models for complex land system science. As an introduction, Dr. Dan Brown is professor and Corkery Family Director in the School of Environmental and Forest Sciences at the University of Washington. Before that, he served as professor as well as associate dean for research and interim dean in the School of Natural Resources and Environment at the University of Michigan. His research is generally interested in understanding human-environment interactions through a focus on mapping and modeling how land use and land cover changes affects environmental and social outcomes. And sort of methodologically, he brings to bear sort of GIS, remote sensing, spatial analysis, and modeling methods, and has also conducted field work all across the world, including North America, Asia, and Africa. I'm particularly excited to have Dan today, as I think his work really covers sort of the urban-rural gamut that we think a lot about in the MSD space, and also sort of interfaces with multiple interacting sectors. So we thought his insights would be really beneficial to hear from our community as we also sort of wrestle with these topics. So without further ado, I'll hand it over to Dan, and I'll stop sharing my screen so Dan can take over.
Thank you, Jim. I'm really glad to be here. This is kind of exciting for me to get out of administration mode and into thinking about some exciting things that I don't have as much time to think about. Now, are you seeing my screen? My title slide?
Yes, we see it.
Great. So I'm really glad to be here. I really like what you guys are up to. I scanned, didn't read the details of that plan, but it certainly covers a lot of the kinds of things that I'm interested in and would like to follow along, certainly, with what you guys are doing. And certainly the work that I'm doing, presenting here, fits within that. I'm going to start with some stage setting that maybe this group doesn't need a lot of, but I'll try to run through it quickly and get to some sort of bigger thoughts to think about for this community. So aiming at sustainability and land systems, I'll talk a little bit about that and then illustrate briefly two examples of applications of agent-based models toward that question of understanding sustainability in land systems, one in the state of Washington and one in sub-Saharan Africa, and then try to bring out two main themes. One, dealing with complexity and prediction in these models, something that we've been thinking about for a while, and want to also point out that all of this work is part of teams, and what I'm going to do is point to the folks who are working on this stuff, and I have the privilege of working with them, including Pranav, who's here today. And so this work on complexity and prediction carries on some earlier work we've done, and have some updates on that. And then some thinking that we've done about sort of how do we bridge this scale so that we can do global modeling connected to these local impacts, which it seems like it remains a real big challenge. But I'm really curious, I have some thoughts, but also interested in what other folks are doing there. So basically, thinking about the shifts, transitions to sustainability. We know we need energy transitions, but that cascades into all kinds of other systems, food, water, and land use systems, and we need a systems approach. Thinking about how governance and institutions and policy influence that transition from the state we're in to where we'd like to be. The graph showing low carbon future, and sort of initially flagging this challenge of difficulties in predicting complex systems. We want to understand what happens if we push the system in a particular way. Is it getting us in the direction of that future that we want to get to? And so we're necessarily thinking about futures that don't exist and moving towards ways to move systems in those directions. And I want to flag in the examples that we have this notion that both spatial as well as distributional outcomes is critical if we're going to implement planning methods in land in particular toward those outcomes, but also in looking at equity, which is essential in thinking of one of the sort of elements of how we might think about a system being sustainable. So this is a graph I've used for many, many years, just describing sort of the thinking about the land system as a system that involves a number of attributes of the land itself, but also of the actors, the choices in land management, land use, the institutional structures of land tenure, the physical characteristics of land cover, and land value within markets. So all of these sort of attributes of the land system that are connected and structured by both the social context and the ecological context, and feedback into both of those. I was fortunate to be involved about 10 years ago now in a study on sort of how do we think about land change modeling in this context of moving towards sustainability, and summarizing as part of this National Academy study, summarizing the approaches that are extant and thinking about opportunities for moving forward. And coming out of that, we sort of arrayed existing modeling approaches along this gradient from kind of data-based approaches, which we call pattern-based, where a lot of the approaches that are being used, we have a wealth of and growing wealth of satellite image data over time, multiple resolutions that we can use to train and learn about patterns and how they evolve, all the way through structuring those models with some process detail, some data on the social system, through economic models, which take much more of a land value actor-based approach, often aggregated, but sometimes spatially disaggregated, through to agent-based models. So on those latter group of models, more process-based, where we're focused on not just learning from the patterns that we see in the past, but trying to characterize what are the decisions and processes that structure the outcomes that we see. And necessarily there's hybrids across all these types, and interplay back and forth between structuring processes and learning from data. In the land cover land use world, we noted that a lot of the land cover based models tend to be more these database models where we have lots of satellite image data. And land use, if we start to get into land use, we're talking about the actual process by which people are making decisions about land use. I want to make this point about process and pattern-based models a little bit more pointedly. A lot of the work in the carbon markets uses these pattern-based models to basically extend deforestation baselines. So we set up carbon credits, or within the REDD+ schemes, identify additionality in carbon credits relative to a baseline. And the baseline is often, so the verified carbon standard uses kind of okay, let's see what the trend has been and extend it forward, and that's going to be our baseline, and then compare that to what we might expect from a given project, and that difference is the additionality of that project. Recent big study of carbon credits shows that the expected benefit of carbon projects is not what was calculated at the initiation of those projects. Largely, a lot of that had to do with baselines that weren't accurate relative to what ended up actually happening in the sort of baseline landscape that the projects were compared to. So, for example, government change in Brazil, you have a significant change in what would happen without the project. And so that's sort of this challenge of figuring out what the counterfactual is in the future, and sort of doing this futures thinking. So I would argue that this is a potential consequence. Introducing process into these models doesn't make the prediction necessarily any easier, but it might help us flag where the predictions can go wildly wrong compared to just a business as usual kind of prediction. So I want to just flag this notion of stationarity being a critical factor in the way we think about predictions, and recognize that any model has an element of stationarity in it. As long as we're using the same structure and some of the same parameters, that model is going to have stationarity. But the example that I gave with baselines is an example with strong stationarity. That is, that you're essentially saying the pattern that we see is going to be unchanged, rather than the process is going to be stable relative to some possibly varying boundary conditions. So how we get from this focus on business as usual to some recognition that the world may not be stationary in the future means developing other kinds of approaches. And what the approach that we've sort of settled on in a lot of the applications that I've been involved with are this sort of notion of controlled stationarity, where we say, okay, well, we can't know what the future is going to be, but there are some ways we can imagine it playing out. And this is kind of pretty well embedded in the IPCC process, this approach of using scenarios and trying to figure out the best bracketing of the possible scenarios so that we can understand what might happen under those conditions. We could think about adaptive processes that also have learning about boundary conditions within the model. And there are some examples of that. That doesn't make, again, prediction any easier, but it does help us start to think about what are the range of possible outcomes. So back to the sort of carbon credit example, just because the model that's fitted over one time period fits pretty well doesn't mean it's going to predict out into the future when the boundary conditions change. So structure and process help us move into a world of being able to characterize that a little bit more. So agent-based models are computer object-based computer programs that represent process dynamics at the levels of individuals and actors and produce system-level outcomes. I often think about them as a scaling from that micro-level process to the macro-level outcome. That's sort of Axelrod's kind of characterization. In order to build these, we have to think about what is the process, what are the mechanisms at the individual level, what are the interactions at the individual level, what are the variations at the individual level, and use the simulation forward to generate the patterns. And these are complex models. Almost by definition, not all of them have all elements of complexity, but the kinds of things that can be incorporated into complexity. We can have heterogeneity in the actors, both in terms of the decision processes that they use. And Jim, I appreciated your sort of broadening the sort of thinking about all the different kinds of actors and all the different scales at which they can operate and the time scales. And the different, we can think about the process by which those decisions are made are different depending on what scale they're acting as an actor and what time scale they're working on. So all kinds of different kinds of decision processes, and then not all the actors, even within a category. We do a pretty good job of talking about different categories of actors. Within those categories, they can have heterogeneous characteristics, wealth or age or family size or whatever. And then they interact and learn from each other. And if you have a bunch of actors acting independently, it's kind of a simpler to just treat it as a well-mixed box. And so you can simplify your mathematics. But it's when you have interactions, you can start to get small world groupings and spread of information and behaviors within a group that is that can produce some nonlinear dynamics in the model. I mentioned the time and space scales. And then, of course, we don't know everything, and we often use stochastic processes to represent what we don't know and try to characterize that well with stochastic processes. We did some work back a number of years ago. Derek Robinson led a sort of workshop and survey of the sort of empirical support, ways in which we support agent-based models with survey data, increasingly sort of transitioning to all kinds of ambient and volunteered information, participant observation and other qualitative methods, field and lab experiments, participatory modeling, and statistical and spatial estimation approaches. Ultimately moving toward being able to characterize the processes and sort of use these models in this sort of scenario approach. And that's kind of as I said, the way we've been doing it, where I like this Al Camo's characterization of the scenario and simulation. We have to think about what ifs. We can think about, well, what are the storylines and how do those then, what are the implications of those storylines for either the boundary conditions or maybe even the structure of the model, so that we can then simulate the impacts of those scenarios. And so here's a couple of examples. Pranab's work here at the University of Washington on forest management decisions. So we've got a number of forested landowners who are making decisions about management. In some cases, whether to manage, in other cases, and then if to manage, in what ways to manage, and with what levels of intensity, with what kinds of approaches. Mostly focused on harvest in Western Washington. There's lots of biomass to harvest, and so we were interested in what are the implications of carbon payments to forested landowners, how are the availability of carbon payments, which we're seeing more and more of here as of interest in the revenue streams for landowners, as well as the potential impacts that they might have for carbon storage. And we focused on rather than given permanence concerns about sort of 100-year carbon credit payments, we focused on an alternative, which was a carbon rental payment, which is essentially aimed at deferring or delaying harvest, rather than sort of this assumption or expectation that we can pay to lock up a particular forest for 100 years. So we were focused on this question of what are the disparate opportunities for carbon storage and the effects of rental market on different landowner types. And so Pranav did all the work. I'm just summarizing. We have these forest owner types, focusing specifically on those forest owner types that could participate in the land market. We see the state sort of dabbling in that, but for the most part, this is for private landowners, large industrial owners, and small forested landowners. Here's a case where we've got two pretty different kinds of decision processes. Large industrial landowners pretty much following an economic model, and at least in our model, that's what they do. And we think that's a fairly accurate way to characterize the decision making there. And then small forested landowners, we have lots of survey data that indicates that it's not just economic rationality driving decisions. There are social considerations, legacy considerations. So you have neighbors and discount rates sort of varying across this group of small forested landowners that are sort of interested in how well they can participate in these markets. So we had a baseline of no market, a market intervention. So we institute, and this is kind of an institutional intervention of a new market for carbon rent, and then recognizing the challenges of scale for small forested landowners, another institutional intervention of introducing cooperatives. And just a quick summary of the results. There's a lot of work, and actually some of you may have heard Pranav present on the details, and it's in the paper. But essentially the results point to the potential benefit of the carbon rental market for increasing carbon storage. On the left, we have the two rental market scenarios with and without the co-ops on the top, and the baseline on the bottom in yellow, showing that we get a big carbon boost and we get a big revenue boost. And this is overall. So on the right is the revenue, on the left is the carbon, and this is overall. But what's kind of interesting is disaggregating the different owner types and seeing that on the top we have the small forest landowners, on the bottom we have the industrial forest landowners. The carbon storage on the small forest land doesn't get that benefit until you institute that cooperative. And there are some elements of the way the market is structured, prioritizing larger projects. They don't have the market. And then there's also the sort of transaction costs that come, and the cooperative is intended to reduce the transaction costs. So we can see how that market mechanism affects actors differently based on scale and also based on their decision-making approaches. So just a broad lessons here. We have heterogeneous agents with different decision structures and market scales participating differently in a market. And both of these institutional interventions, the market and the cooperatives, interact with that agent heterogeneity. And so the notion of agent heterogeneity is really important. And in the small forest landowners, it's not just the difference between small forest landowners and industrial landowners. There's also variations within the small forest landowners by size that we showed how even within that category, the size of the ownership really matters. And one of the things that we can do by simulating is see the transient dynamics from the sort of the current state to the future state. We don't see necessarily any sort of tipping points in this case. These social models where you do have social learning can result in those kinds of tipping points, but like I said, we don't really see that in this model. Second example, we're looking at the influences of large-scale land transactions in sub-Saharan Africa. So these are big farms that are leased or sold to either domestic or international corporations. It's a sort of resource-led development strategy in these countries to bring capital intensive agriculture. We're working in Ethiopia, Tanzania, and Liberia, and have a couple of big projects, NASA and NSF funded. So there's a whole kind of empirical strategy to identify the impacts of these things. We're also using agent-based modeling to sort of pull the empirical pieces together and look at, again, some possible institutional interventions that might influence the outcomes of these things. So we're interested in both the social and the environmental outcomes associated with these large land transactions. And so Tim Williams, who's now at Free University of Amsterdam, has, I think he's moving to Karlsruhe sometime soon, did some scenarios on what happens when you bring these large-scale land transactions and different ways in which smallholder agriculturalists in the region can participate or not in that capital-intensive farming. So we have three scenarios where you have a baseline with no land transactions. We have a displacement kind of approach, which says, okay, here's this large-scale land transaction. You smallholders have to go. A lot of these are in sort of common land that is used by farmers. So there can be displacement. And so essentially the farmers have to go to the rest of the land in the area, or they have to leave. And then we see in a number of cases contract farming where the local farmers can participate in the farms. And so we have two cases here where the people who are in the area, if they want to keep farming, have to participate in the contract farming, have to participate in the large-scale farm. And then a second contract farming scenario where they have the choice to participate in the farm. And so we have a structured agent-based model that Tim built, essentially focused on the annual decisions of the farmers, looking at the food security outcomes of the farmers as well as the income as affected by sort of a weather simulation and then some assumptions about price variability on the crops. And then they have other things that they can do besides cropping. They can have livestock and wage labor income. And so what his analysis shows, so again, we're looking at sort of the distributional impacts of these things. So not all small forest landowners are the same. We do see a pretty consistently negative effect on food security of displacement, but a slightly positive impact of contract farming and a more positive impact for the lower income households. So the ability of lower income households to participate in the farm results in a greater differential from the baseline to this scenario. And so this again is an example of agent-based models sort of helping with the distributional effects of outcomes, and also looking at these interventions, institutional interventions as scenarios. So I want to spend a little bit of time to just talking about predictability and complexity, and related, come back to this example of the large-scale land acquisitions. Two problems in prediction. One is equifinality, which is sort of an inference problem. We want to try to explain something that we see, some phenomenon that we see. We can measure the thing, and we have alternative hypotheses alternative models for what explains that thing. If there are multiple alternative models that all fit the data, it can be challenging to adjudicate among what's the right causal kind of mechanism, and this can happen, particularly in noisy systems. And the other sort of aspect of the prediction challenge is multifinality, where when we do have complexity, path dependence, variability, stochasticity in our models, we have models that can produce sometimes pretty wide ranges of outcomes that maybe the reality matches pretty well one of those, but the model can produce lots of other outcomes. Are those outcomes less likely than the one that we have observed in the past? Because we want to, again, make predictions about the future where we actually don't have the data to fit. And so I want to sort of, we thought did some work a number of years ago looking at path dependence, and where in reality the processes that can produce the observed pattern might have some small influences that created a path-dependent outcome that might have gone a different way if the conditions had been different. And so you might have some really different realities that could have come out of that process. And the challenge, this goes to the challenge of interacting between models and data, and the potential that if just because a model fits the past observations well, doesn't mean that it's the most accurate. And so this was a paper that argument that we made in this paper a number of years ago, almost 20 years ago. And there are dangers in overfitting to the data. And so we have to be careful about the way in which we interact with the data. And we have a number of ways of mitigating, but Tim Williams came up with a really interesting approach to dealing with this equifinality problem. Essentially, if we follow the gray arrow around the circle, we have this question, we develop hypotheses that are kind of embedded in a model, we parameterize that model, and then we validate it in some way, maybe in other locations at other times, and try to say, okay, independently, do we see that it fits as a good predictor of what we see happening? And then we might use that model to analyze some scenarios. What Tim did was take the structuring and parameterization steps and say, well, what if we had multiple parameterizations or multiple structures? And we can think about this as sort of good practice from a strong inference. If we want to actually explain something, we should have some alternative comparisons among alternative explanations. And for the particular problem of the large-scale land acquisitions, he developed this approach to genetic algorithms to generate multiple calibrations. So the traditional approach, calibrate the model, and you use the calibrated model to evaluate the outcomes. In his genetic algorithm approach, essentially an optimization approach, optimize the parameters, but he optimizes them to do two things: fit within some tolerance relative to the observed data, as well as generate multiple versions that fit within the tolerance relative to the observed data and are as different from each other as possible. So he's trying to force the parameterization to create as wide a diversity of models that fits the data as possible, so that then we can say, okay, given these multiple models, how do all of these models behave relative to the interventions that we're looking at? Now, in this case, this is a different paper and a kind of a different example where he used two different interventions, providing, and it's a drought resilience kind of application. Again, food security is the outcome. A drought hits. Do you provide weather information is one intervention, and job availability off the farm is another intervention. How do they do? And so you can see the parameters at the top. They actually vary quite a lot, and he essentially forced them to vary quite a lot. And what he finds in the results is that this is four different models, and these are the median responses of those models, that essentially the relative ordering of the different interventions is unchanged, even though the models are really different. And so it's a way of saying, okay, do we have to worry about that sort of variability in the model parameterization, or we get essentially the same results, which I guess was fortunate for him that it did, because it raises all kinds of questions then if it doesn't, which models for what purpose and so forth. I want to just end on a comment about crossing scales, because it seems like that's what's ahead for this group, or if it's not ahead, it's sort of ever present for this group. How do we go from incorporating this kind of age and heterogeneity, and admittedly, the examples that I've been involved in and that I presented are pretty small scale applications. And how do we go from that to connecting to global scale, national, regional scale processes, policies, interactions? We get this interaction among heterogeneous agents driving outcomes at larger scales, but we don't really have very good generalizable models that we can apply everywhere for all decisions. There's a group in UK, Mark Ronsfeld, he's at Karlsruhe now, developed this CRAFTY, which is sort of a decision maker typology. So their idea, so this proves my statement wrong to some extent. They're trying to generalize the approaches to decision making and representing decision making. So that's an approach. On the flip side, we have global models, and GCAM is something that certainly folks in this group must be aware of and involved with. So one approach is sort of scaling up these agent-based models and develop. And Rob Axtell talks about, why not 8 billion agents? I think the question is how do you structure it? Because there's all these things in between. It's not just 8 billion agents. It's the firms that those 8 billion agents coalesce around, the governments, the agencies, all kinds of structure there. So I think that's a challenge, but it's also a challenge then to bring these, in a way, GCAM and integrated assessment models simplify the decision making to representative agents within sectors and within regions. And as the last version I could find, looks like it has 151 land use regions. So, and then multiple sectors within that, represented by representative agents. You miss all that heterogeneity. And so the question is, what do we lose by missing all that heterogeneity? And is there benefit to sort of integrating these global models with these local models so that we can benefit from that heterogeneity and those interactions and learning that we get from them, and also articulate that with the global system. And of course, all of these are connected to Earth system models. This is one of the sort of things that came out of that National Academy study, this notion of the need to do this integration across scales and across models. One of the things that I sort of have had stopped thinking about for some years, not because it was solved, but because I found that I didn't have time to do it. And the proposal wasn't funded when we did submit it a couple times, was this notion of, okay, can we articulate these global models and these local models to work together rather than trying to take one model as this single solution? And we talked about sort of managing that integration through maybe sampling to get at what is the variability that so that we can actually learn what is the variability that we're missing, or the possible nonlinear outcomes that we're missing in these global models by running local models sampled within these larger regions, or doing some work to understand under what conditions do we get divergence between the representative agent model and the multi-agent model. And so that we then do a sort of responsive approach and say, well, okay, these conditions hold, so we need to run a multi-agent simulation to incorporate those dynamics into the larger model. So these are just some thoughts. I'm really interested in sort of where this group is going with those kinds of things. And then just point to, I don't know if this group is connected to some of, there's a whole group of sort of agent-based modelers, of course, the ODD protocol kind of as a way of making the models discoverable and decipherable to greater or lesser degree, depending on how you think about that protocol. The ComSysNet is a NSF-funded network out of Arizona State, and they're sort of launching this open modeling foundation. Certainly, seems like there's a lot of potential benefit to collaborating across MSD and this group. So general point, sustainability requires thinking about the future in complex systems. We need process-based modeling, and process models of complex systems are we confront these multi-finality and equifinality issues. And so we have to think of it not necessarily just as distributions or stochastic phenomena, and that there's structure to it. And then there's opportunity for this cross-scale interaction between models. So thank you. Thanks for the opportunity to interact. I look forward to hearing more from you.
Great. Thanks so much, Dan. That was wonderful. Yeah, we have about 10 minutes or so here for questions and discussion. So if you do have a question, feel free to raise your hand in Zoom, or we can or drop a comment into the chat box here. I'll perhaps kind of start off with a question, Dan. I really like kind of the spectrum of strong stationarity, weaker stationarity, or strong stationarity, controlled stationarity, weaker stationarity, and kind of identifying a lot of your work within that more controlled stationarity zone. Yeah. It does seem to me that a lot of what is treated as a scenario has to do with the institutions at play. And so, like, for example, in Pranab's work, where you kind of presuppose a co-op exists or it doesn't exist. Yeah. And I guess the question I would have is, do you see any opportunities for actual like endogenous treatment of those types of institutions that involve cooperation, lack of cooperation and such? And yeah. And is it, and kind of what would be your sort of thoughts or vision on that particular front?
That's been there as in sort of the goal of representing how endogenous institutions form. I haven't had the opportunity to work on it. We did do some work in India sort of commons context with Arun Agrawal, who's an institutional scholar, and in that work we got probably as close to this notion of essentially the goal. So he's really interested in this notion of formal and informal institutions, and so we imposed a formal institution. So that was sort of like, okay, let's set up this thing and make it work. Here are the rules and that sort of thing. But then in that modeling work, we said, okay, but not everybody's going to pay attention to that. It depends on enforcement, and it depends on kind of what everybody else is doing. And so we had endogenously the actors responding to the institution and whether or not they paid attention to it or not. So that's kind of the closest we got. But I think that the notion of sort of negotiating rules could be part of how you operationalize that. I'd have to give some more thought to how you might program code to create one. To just out of whole cloth say, we need an institution, let's set one up. So the agents decide that. I think there has to be the capacity built in for some sort of structure and collaboration, and then this notion of moving in and out. Although there could be some really cool, more detailed behaviors using kind of AI, machine learning kinds of approaches that allow for the construction of agents that have certain characteristics and interact with other agents in particular ways. And I think it'd be cool to see somebody do that.
Yeah. There's a lot of interesting work in sort of the generative agent space around kind of tapping large language models to like deploy a sim type universe where the agents congregate. So yeah, pretty neat. Yeah, again, if anybody in the group has a question for Dan, feel free to raise your hand. I see, Philip Womble.
Hi, Dan. Thanks for the really interesting presentation, and good to see you, Jim. So on the carbon markets work, I was wondering if your modeling speaks to or has implications for threats to forest carbon offset integrity beyond additionality. And I think that this kind of speaks to some of the broader discussion about agent representation and multi-scale heterogeneity that you raised. So like, for example, there's been a lot of press recently in Washington and I think other places about how unexpectedly high carbon auction revenues and like potential or real impacts at this point on gas prices could lead to cost-cutting measures in the carbon market, like linking up with California and Quebec's forest carbon markets, which have some pretty well-documented shortcomings in the forest carbon arena. And that pathway, right, where carbon market or carbon tax leads to concerns or real increases in gas prices leads to reduced integrity of the carbon market, is something that's been observed elsewhere, right? So I guess I'm just wondering if like your work speaks to that or contemplates it or has implications for that.
It's a perfect example of why we would benefit from articulating these local models with some sort of regional model. We very much left the price. So the market was not endogenous in the model. And so the price was kind of, okay, here's this sort of steadily increasing price. But there's all kinds of reasons why that might not happen. And we deal with it by recognizing that scenario is what it is and has some uncertainty associated with it. And in the little sort of, we were dealing with a small area in Western Washington that isn't going to have enough, whatever the agents do here isn't going to have, and you're right, there's other agents all over the state who are responding to gas prices or, political and providing political pressure to sort of modify the market. So that would require some interaction between this local area and the global or the statewide politics and market for these credits. That notion of institutional, so that's not quite the same question that Jim asked, but it is kind of the institutions are endogenous. And that particular one very much requires crossing scales. We did some work in southeastern Michigan on local land use planning, and contemplated and started to look at the interplay between zoning policy and outcomes that people were cared about, like the naturalness of the landscape and the tax base of the community, and how that plays in, how that feeds back to policy. So policy in that case wasn't, we did some looking at the kind of games of neighboring townships that are making decisions and how those are affected by the outcomes that the results of individual actors feeding back to what the township cares about, and then looking at how the townships play off one another in terms of getting what they want. So that notion of endogenous feedback to institutions is really important. And I think that's why we have to have these articulated sort of sector-based models and individual-based models.
I maybe have one last question here before we wrap up today. You mentioned, you talked about sort of empirical supportive agents and described survey work, sort of RPGs and so forth. Like and this is always a challenge in age-based models, sort of what is the data we can use to support it. I'm wondering if you had like an empirical genie, so to speak, like you could sort of, what are the sort of, and I guess another way of saying that is like, what are the main data gaps? Like, is it more on individual behavior side? Is it more sort of having observations at societal scale through which you can kind of validate your models? Like what's the future you think in regards to sort of empirical data and these types of models?
No genies. I did present at a complex systems meeting a number of years ago, and the big sort of theme was big data, and I described our work as using artisanal data, because it seems like there's just not a single, because you're focused on specific kind of either information that an agent needs to have or decision processes that an agent needs to engage in. There's just not a single source for that. There are some interesting kinds of the social media kind of, if you're worried about social media behavior, that's a great source of data, but we aren't necessarily only worried about social media behavior. We actually are interested in people in the real world. So survey data is good, usually good at getting, and we sort of dig into that a little bit in that review paper, or sort of what the different sources are good at. What most of them, what's most challenging is the how to get at how do people make decisions. And we know that we have the kind of stated preference survey stuff that we use to sort of get at. And we did one paper where we just say, okay, let's take the stated preferences kind of relative and see, you know, what's the effect of the heterogeneity in those stated preferences and different ways of representing it. But it's not necessarily a good absolute kind of, it doesn't give you the weight on different factors necessarily. But then the sort of next general category, and I see the comment from Dale, sort of revealed preferences, where we actually put agents into a decision context where there's real or perceived consequences, like in the real setting, and say, how do you make that decision? And games absolutely are a great way to do that. And I think the work of the Cormas group in France and sort of taking these games out into the wild and having them represent as best as possible some characterization of the system, and sort of engaging the actual decision makers in making actual decisions, and then characterizing that process as best as possible. And that's kind of a combination of games and maybe some interview ethnography, I think, because they don't just do the game and then walk away apprehending the decision process. They talk through the process with the agents.
Great. Well, I know that we're past the hour here. I know you have other things to get to, Dan. We thank you so much for joining us today and giving a great talk. It really hits hits home for a lot of the issues that we contend with within MSD, particularly that sort of how to cohere kind of or harmonize across scales. It's kind of a perpetual challenge with all of our work. So thanks again for all of your insights, and we hope to stay in touch as a community.
I look forward to hearing more.
Great. Thanks so much, and thanks everybody for joining. Have a good
Thank you,
one.
Dan.
Thanks. Bye.